All right, so welcome back to our geology lab. The very first week of school, we conducted an experiment in this room, and that experiment involved a chemical known as ammonium phosphate. So the chemical experiment basically was as follows. We took different concentrations of ammonium phosphate and we dissolved it in an equal volume of water, all at the same temperature. All the conditions were the same, except there was one variable. And that one variable was simply the concentration of ammonium phosphate. So both the Tuesday and the Thursday class came up with at least 3 hypotheses. So I've combined the Tuesday lab and the Thursday lab. Since these 2 labs have been linked all semester and students have switched back and forth, attending different labs as they weren't able to attend the lab that they would normally attend. And since I linked the 2 classes, I decided to link the 2 groups of hypotheses. So each class had about 3 hypotheses, a total of 6. We condensed it down to 5. And so here are the hypotheses between the 2 classes. A thick base will produce a larger number of crystals. Hypothesis number 2. Solutions with a thick base, that's the precipitate that forms at the bottom, and I'll show this in the camera when we look at the crystals, will grow smaller crystals. Hypothesis number 3. Greater concentrations of ammonium phosphate will grow larger number of crystals. Hypothesis number 4. Smaller concentrations of ammonium phosphate will produce smaller crystals. And hypothesis number 5. No crystals will grow at all. So let's take a look at this experiment. We did this the very first week of school. So this is week number 14, I just now removed the crystals, and some of them were still wet, still moist. They're basically done growing. So let's take a look at our crystals, and then let's look at this hypothesis, and we'll go through hypotheses 1 through 5, and they're either going to accept these hypotheses or we're going to reject those. So let's look at the crystals. So here are our 5 groups of crystals. Starting here with this green one, this had the smallest or the lowest concentration of ammonium phosphate at 300 milliliters. And these are the crystals that were formed as a result of that experiment. The second one, kind of a light red pinkish. This is 325 millimeters, so this is 25 millimeters more than number 1. And these are the crystals that developed. So all these were placed in the same room, same temperature. Sample number 3 is 350 milliliters. And these are the crystals that formed as a result of that. Sample number 4 has 400 milliliters. And the last sample, number 5, has the highest concentration at 425 milliliters. And these are the crystals that grew. So scanning from number 5 back to number 1. Here's number 4. Number 3. Number 2. And number 1. All right, let's look at the hypothesis. I think hypothesis number 5 is an easy one to deal with, so we'll deal with it first. No crystals will grow. I think we can safely reject that hypothesis, so we're going to reject that. All right, number 1. A thick base will produce a larger number of crystals. Let's go back and let's test this. So a thick base will produce a larger number of crystals. And number 2, solutions with a thick base will grow smaller crystals. So both of these, number 1 and 2, are opposites. One is saying that you're going to have larger crystals with a thick base. The other one is saying you're going to have smaller crystals. So a larger number of crystals simply means a quantity of number, many crystals. And number 2 basically says that you're going to have smaller crystals with a thick base. So let's look back here and let's first define what this thick base is. So going over here. So the base, you'll notice, varies. The concentrations of lower ammonium phosphate basically form a smaller base. And so a more thicker solution will form these thicker bases. And a lot of this base was lost when I removed the crystals. The base basically separated. So the ones that had the larger bases were certainly numbers 4 and number 5. And you can certainly see how number 5 had a very thick base. And even number 4 had a very thick base. And so looking back at those hypotheses, number 1 says that a thick base will produce a large number of crystals. So this certainly has a thick base. And panning over this, there's a large number of crystals in there. I would say there's a much larger number of crystals than there are at number 3, which has a very small base. So 3 has a pretty small base. It has some of the largest crystals, but not as many. Even with number 4, which had a pretty thick base, there's a large number of crystals, but these crystals are actually larger. So these crystals are actually larger in size than you find in number 5 with a thick base. The thickest base of all has lots of crystals. They're certainly smaller than certainly number 4, which has a thinner base. And they're way smaller than number 3 with a very thin base. And even if you look at samples 2 and samples number 1, these crystals are much larger. So as it turns out, as we go from number 1, 2, 3, 4, and the last number 5. Number 5 has the smallest crystals. It has many crystals because they're small, same volume, same area. A lot more crystals could grow because there were no big ones to stand in the way. So let's look at these 2 hypotheses real quickly here. A thick base will produce a large number of crystals. I think we can accept that. Number 2, solutions with a thick base of precipitate will grow smaller crystals. certainly if we look at number 5, we see that. So we can accept that hypothesis. So we're going to accept hypothesis number 1 and hypothesis number 2. Number 3, greater concentrations of ammonium phosphate will grow a larger number of crystals. So again, they're saying that the greater number of crystals are going to result from the largest concentration. So the largest concentration was this 425 milliliter. And if we look at this, we can certainly see a large number of crystals. And the same could be said for number 4, which has 400 millimeters of ammonium phosphate. And the number 3 with 350 millimeters, not as many crystals, but these crystals grew pretty large. And something that we kind of discovered here is it seems like if you wanted to grow large crystals, then a solution that contained 350 milliliters would have been that optimal solution for growing large crystals. So this is something we learned. It was not part of our hypothesis. Nobody came up with an idea or a hypothesis that there would be the ultimate precipitate concentration that would grow very large crystals. That's something we learned in this process. Number 2 is kind of a strange one, 325 milliliters. There are some really good sized crystals in here, and a lot of small ones. And then number 1, which had the lowest concentration, seems to have some of the most spectacular, longer, taller crystals that grew. So after looking at solutions 1 through 5 here, let's revisit this hypothesis. Greater concentrations of ammonium phosphate will grow a larger number of crystals. I think we can definitely accept that hypothesis. So number 4, smaller concentrations of ammonium phosphate will produce small crystals. Smaller concentrations of ammonium phosphate will produce small crystals. Well, if we compare number 5 here, which had the highest concentration of ammonium phosphate at 425 milliliters, these are small crystals, and I'm going to move this over. I'm going to compare it to number 3 here. So number 3 had 350 millimeters, and look how large these crystals are. Whereas the 425 millimeter solution had small crystals. And then if we go over here and look at number 1, very small concentration, the smallest concentration at 300 milliliters, and yet it grew very large crystals. Larger crystals, I'm going to move this over just for comparison, certainly much larger crystals than the highest concentration. So it seems as if the smaller concentrations grew larger crystals, and the larger concentrations grew smaller crystals by looking at our crystals. So when it comes to hypothesis number 4, smaller concentrations of ammonium phosphate will produce smaller crystals, we're going to reject that hypothesis. So, just to recap, we're going to accept hypothesis number 1. Thicker base will produce a larger number of crystals. So I'm going to put down accept. Solutions with a thick base precipitate will grow smaller crystals. Certainly we saw that in solution number 5. Again, except. Greater concentrations of ammonium phosphate will grow a larger number of crystals. Again, we're going to accept that also. But then when it comes to smaller concentrations of ammonium phosphate, will produce smaller crystals. We're going to reject that. And no crystals at all will grow. We're going to reject those. So we're going to reject 4 and 5. So basically, sorry about the focus of the camera. A thick base will produce a larger number of crystals. We're going to accept that hypothesis. Solutions with thick bases, the precipitate will grow smaller crystals. We accepted that. Greater concentrations of ammonium phosphate will grow a larger number of crystals, except. Smaller concentrations of ammonium phosphate will produce smaller crystals. We reject that, as well as hypothesis number 5, no crystals will grow at all. So this is by the scientific method. It literally took about 11 to 12 weeks for these crystals to grow. But one thing we learned out of this, in addition to any of the hypotheses that we came up with on week 1, we realized that if you want to grow very large crystals, certainly it seemed like the best or the optimal amount of precipitate turns out to be about 350 milliliters. And also, I was pretty impressed with the crystals that came from the 300 millimeter solution. So these are some pretty nice crystals. Nice form to them, nice prisms. And that was at a much smaller, so I think I was looking for a static looking crystal, for a crystal that to me was really nice looking. My favorite, and this is my personal bias, would be number 1, the 300 millimeter. And I also like the 400 milliliter. The 500 milliliter, a lot of small little crystals. And some people like small little druzy crystals. I prefer the larger crystals. And that's a personal preference, and that is subject to bias, which we all have. So what you're going to do is you're going to go into Canvas. So for number 1, a thick base will produce a large number of crystals. We're going to mark true. We accepted that hypothesis. So this is what it's going to be. It's going to be a true-false. True means we accept a hypothesis. False means we reject it. Number 2, solutions with a thick base, the precipitate will grow smaller crystals. We're accepting that hypothesis. Number 3, greater concentration of ammonium phosphate will grow a larger number of crystals. Again, that's going to be a true answer. We accept. So questions number 4 and 5 are both going to be false. We do not accept these hypotheses. A smaller concentration of ammonium phosphate will produce smaller crystals. We rejected it. That is a false statement. And number 5, no crystals will grow. Again, a false statement. Now, some people might say that was a pessimistic statement, but there is a probability that no crystals will grow. Something could have happened. An earthquake could have occurred. The containers might have fallen over and all the liquid would float out onto the floor, and we would have lost the environmental conditions to grow these crystals. I've seen times where one of the first times we did this with salt and sugar, we had basically pathogens, parasites, mold, got into the salt crystals and destroyed the salt crystals, and also the sugar crystals, especially the sugar crystals. And so there's a probability that something could go wrong that mold could actually interfere with the growth of crystals, and so no crystals will grow is a viable hypothesis. In this case, fortunately for us, since we wanted to grow crystals, it didn't come true. So we rejected it. So A, so number 1, true. 2 is going to be true. 3 is going to be true. Both 4 and 5 are going to be false. And that concludes this lab and this semester. So we are through with this portion.